For more practice of basic trigonometric identities, let's do a couple of more questions. In question number 1, we are given range alpha for which sine alpha is given 4 over 5, and we are also given range beta for which cos beta is equal to 40 over 41. We are required to find the value of sine alpha minus beta. So let's write down the angle in the first triangle and call this as range alpha, and for the second triangle let's use this triangle for range beta. For sine alpha is equal to 4 over 5, means 4 is the opposite and 5 is the hypotenuse. So hypotenuse is equal to 5. What we are required is adjacent because that is missing. And for the second triangle, we are given cos beta is equal to 40 over 41, means base are adjacent, that is 40, and hypotenuse is given equal to 41. So this is adjacent and the opposite is not known in this case. So let's first find all the other trigonometric ratios by calculating the missing side of the triangle. Here, by applying Pythagoras Theorem, hypotenuse square is equal to base square plus perpendicular square, and hypotenuse is 5. So this means 25 equal to base are adjacent, this is what we want to find, plus perpendicular is opposite, that is 4, so its square will be 16. So adjacent is equal to 25 minus 16. This means adjacent is equal to 9, and by taking square root, adjacent will be equal to 3. Because it's a length, so we'll take only positive square root. So this is equal to 3. Exactly same way, we will apply Pythagoras theorem on the second triangle, which is hypotenuse square is equal to adjacent square plus opposite square, mean this is 41 square equal to 40 square plus opposite square. So from here, opposite square is equal to 41 square minus 40 square. Now this 41 square is 1681 minus 1600, and in next step we are going to take square root, so opposite will be equal to square root of 81, and this is equal to 9. So the opposite is equal to 9 here, and now the range alpha and range beta are known for all the sides of the triangle. Therefore we can write the trigonometric ratios as sine alpha is equal to 4 over 5, sine alpha is equal to 4 over 5, cos alpha is equal to 3 over 5, and tan alpha is equal to 4 over 3. Tan alpha is equal to 4 over 3. Similarly, for range beta, we have sine beta is equal to 9 over 41. Sine beta is equal to 9 over 41. Cos beta would be equal to 40 over 41. And tan beta would be equal to 9 over 40. Now, the very important point that you're going to overread if you don't really pay attention to it, which quadrant is the angle alpha? The alpha is in first quadrant. Here in this statement, it's given that 0 is between alpha is between 0 and pi by 2, which means that the angle alpha is in the first quadrant, and also in the range beta is given in the first quadrant as well. Therefore, all the values of sine alpha, cos alpha, tan alpha, and sine beta, cos beta, tan beta will be all positive. But if it was given a different quadrant, you would have to make the sine, cos values positive or negative depending upon the quadrant. And just for the guide, if this is a circle and this is first quadrant, here all values are positive. S, T, and C means in fourth quadrant cos is positive. So this is first quadrant, second quadrant, third quadrant, and fourth quadrant. So you use your discretion to find out in which quadrant what is positive, what is negative, and question to question these positive and negative signs will differ. Anyways, because alpha and beta were given in the first quadrant here, so all the values of sine and cos are going to remain positive. So now we can find the value for sine alpha minus beta. So let's find out value for sine alpha minus beta. Since sine alpha minus beta formula is equal to sine alpha cos beta minus cos alpha sine beta, and the value of sine alpha is 4 by 5. 4 by 5 times cos beta is 40 over 41. 40 over 41 minus 3 over 5 times 9 over 41. 9 over 41. Therefore, this would be equal to 160 divided by 205 minus 3 9 times 27. 27 over 205. As 205 is common denominator, so this would be equal to 205 160 minus 27, which is equal to 133 over 205. So for the next question now, we are given to prove that tan 37 degree is equal to cos 8 minus sine 8 over cos 8 plus sine 8. So let's get started with tan 37. So question number 2, tan 37 degree. Since 37 degree is not a well-known angle and it would be difficult to find its value on the unit circle, but we can find its value equal to tan of 45 minus 8. If we can write it like this, that is a clue for creating the right hand side. So now use the trigonometric identity for tan alpha minus beta. This would be equal to tan of 45 degree minus tan of 8 degree divided by 1 plus tan of 45 degree into tan of 8 degrees. So tan 45 degree is equal to 1, since tan 45 degree is a well-known angle and tan 45 is equal to 1. Therefore, this value is 1 minus tan 8 degree over 1 plus tan 8 degrees. Now if we write down the value for tan, like sine 8 degrees over cos 8 degrees divided by 1 plus sine 8 degrees divided by cos 8 degrees. If we take LCM in the numerator and in the denominator, this will be equal to cos of 8 degrees minus sine of 8 degrees cos of 8 degrees plus sine of 8 degrees, and the numerator and the denominator both have denominator of cos 8 degree and here cos 8 degree, which will cancel out with each other, and what we will be left with is just this expression on the left side. So this is equal to cos of 8 degree minus sine of 8 degrees over cos of 8 degrees plus sine of 8 degrees, which is equal to left hand side. See you in the next lesson.